Long time no see, Jasil. Let me see. See. Jasil, you resize it or delete?
Yes.
Because it has a lot of delete.
Yeah. കഴിക്കുന്നവരെ എന്നോട്
Francisco?
Yes? Yes, Jasil?
Yeah. എന്താണ് yeah. I deleted some unwanted files from there.
What did you do? Did you remove?
Yeah. Before I am using JQuery server there, I moved
Ah,
from
you also resize. No. You delete, you see?
yeah.
You see, Jasil, you did not resize, you just delete all the things.
Yeah. Not all the things.
Oh, are you saying something?
No.
Yeah, I mean, what you did is 319, isn't it? You were 390.
390.
Yeah, you delete this Jekyll server.
No, not
But
this. Previously, I have the another folder like JQuery server. This is the
I
record
hear you
folder.
very badly because you are far away from the mic. Well, well, you have 38. It's okay. Now the next one in danger now is Kavita. Let me check. Uh, Hmm. Wrong button. Okay, I'm back. Um, Regarding the machine assignment, we're going to leave it like this for now until you receive the gestalts, unless you have something, because now here it comes. Remember, today we have recitation. Today is Jesse Baker provenance. No idea what is that about. Hmm. Looks interesting. The provenance. Never heard of that. The government proposes to give free and transparent access to the world supply chain. Starting now. Kavita, I saw you arrive. You are the next one in danger to go under the shop door. Because Yasil fixed this folder. Uh, Let me check. Okay, yes. This week is coming one of the most important weeks of FabAcademy. Input devices together with output devices. I just want to make sure that you have most of these components at least. You have the sonar? You have this sonar?
Yes, we have.
Oh, what?
Yeah, we have the sensors only. There's no module.
Who's that?
Vinod.
Vinod, you have to lower your mic level. Your mic level is at full.
Okay, fine.
Or you have to speak uh, separate from the microphone. Can you repeat, please? Well, this wasn't in the inventory before. It's very cheap. I think it's €2. This you have the whole effect. I know for sure. I saw it. Uh, this I don't know, but you can. Do you have this? The motion
Yeah,
sensor?
we have this in Kerala Data Mission office.
Okay.
Here we have around 10 sensors is there.
Okay. How did he? I do not recommend what he's doing here, like soldering this straight away to the board. It will last for very few days. Not very strong. Unless, well, maybe he's not in this picture, but maybe he's also supporting in here. This you have, this you have. These are all of these are SMD components that you have. Then accelerometers, there are many versions, so I don't know if you have this. It is the accelerometer. In many cases, these components, they are very sensitive and they need 3.3 volts. And you will have to add this DC to DC 5 to 3 volts converter that you already have also in your inventory. This accelerometer is new. I don't know you have it. Then sound, this microphone is the original one, but now they have another MEMS. Do you have this?
No.
This is a MEMS microphone, and the difference is that
We have this.
you have it or not have it. You do have it? Well, it's basically the same. You can see here, in the electret, you have to make this amplifier. The MEMS already have the amplifier inside.
Yes.
For all of these things, you will need to study again the datasheet. I'm going to tell you how to set up this device. For example, this is the yeah, and here this will be a very interesting thing. With a step response, you can measure resistance, capacitance, inductance, position, pressure, proximity, tilt, acceleration, humidity, touch sensors, multi-touch sensors. Only with a piece of copper, a resistor, and a capacitor, you can do all of this. And a microcontroller. So this is one of the things I want you to try when we are going to do input devices. Because as you can see, you can make your keyboards or whatever you want only with copper. No need to there will not be need to buy buttons. And also this can go through materials. What is that? This is new from this year. I don't know what is it. Maybe Neil will tell us.
The Agilent is the company of DSO, MSO.
I don't know if you have this strain gauge. I didn't see it. When I got there.
We don't
But
have
these things. Sorry?
Kavita has one, she says, but we can actually print this strain gauge.
Yes.
Exact
That's
copper.
why I'm telling you. You see this 67 thing? You can mill this.
Yeah.
Or also cut it with the vinyl.
Yeah, but the only problem is that these guys are not using copper. What we have is copper. Copper has high conductivity. That will be the problem. But still, we can do it.
Yes. If someone wants to do this, strain gauges, I recommend him to go to step response. Oh, then image and all of this. He's using this camera. €15 camera. Or USB cameras. And this is what? This is for USB cameras, maybe. I don't know what he's showing. Embedded Linux board. This is for Raspberry Pi to hook at OpenCV. Okay, to my conclusion that you have designed. Okay. So this week is gonna be busy, very busy. Okay. Then next week we are doing composites. Punit, do we have the resin there?
What we have silicone, we have polyurethane plastic. We don't have epoxy yet.
But
We
no,
can buy it from Amazon.
your mic level is very low, or
No, I'm talking to the mic. Can you can't hear me? Can you hear me?
then this is not the mic you are using then.
What about now? No,
Yes, let me see.
I'll keep it.
Can you talk?
Yeah. What about now?
Yeah, better.
Yeah. So I was looking at you, looking at the screen, and then talk. That's right. Yeah. We don't have epoxy. We have silicone and we have polyurethane plastic.
But wait, you are talking. Can you do like this to the microphone?
You want me to face the microphone?
Yeah, like do like this.
I mean, like this is my microphone in my hand.
Yeah, can you do like this to check?
Did you hear that?
No.
No. Yeah, like I'm also receiving very low output from it.
No, this is not the microphone you're using then.
The level of audio. Yeah, it's not receiving. No, it's not receiving. Hang on.
How about now?
No.
Yeah, it is. I think this should be good, right?
Yeah.
Okay. Yeah. Um. This is better, I think.
But still, it has echo. It shouldn't have echo, and
How about now?
Very low.
Frank, can you hear us?
yes, but not very well.
And some problem, right?
So while you are fixing this, who has trouble with electronics? Rita,
First,
did you finish all your electronics assignments and programming?
you got to hold the mic.
Yeah, my electronics assignment for electronics design or embedded.
Yeah, both.
Okay, so embedded is almost done because I took a board that was already finished. I still have not been able to mill my Hello World board because of some unrouted wires.
Uh-huh.
So all of the files, everything should be on my website, so you can take a look. Maybe if you can help me. And embedded devices, I've almost done it. I just need to finish writing it. That I've been able to do.
Okay, you are doing this with another board?
Yes.
Okay, and the problem with your board, which is?
The problem is I have not been able to mill it yet because it is not routing. Like when I run the auto router, it's all the wires are not being able to be routed. So I'm still trying to correct it. If you look at my page 6, assignment 6, you will see the up to the level I've reached. Electronics design. So yeah, if you go down all the way, so this is the problem I'm having. You see the two wires
Uh-huh.
not be routed. I've tried the methods, not able to do that.
Okay, but you can do this manually.
Yeah, so I've tried, but I have not been able to succeed.
Hmm. First thing, these wires here are very close one from the other.
Right, yeah.
These two, this also. Did you follow the second tutorial where it explains how to do this manually when the auto root fails?
I think I have to watch it again. I watched it in the beginning a long time ago, so I have to watch it again.
You have to watch it because even the auto routing does some things that you see here is not very good, the job that it's doing.
Yes.
Because like doing like this, you see, for arriving from here to here, it's blocking you a lot of space.
Yes.
And also these are very separate apart.
Yeah.
You have to later, after you run the auto root, you have to manually modify.
Okay.
So you watch it again and modify this design, because this design is not going to work very well.
Yeah, no. And that's the reason I have not milled the board yet.
Yeah, and also you have to play with the placement of these items.
Yes.
Okay. For example, this you see there are a lot of traces going from the microcontroller to this part.
Yes.
So this gives you a hint that this shouldn't be like
Yeah, it
that.
shouldn't be so far.
This should be better where the button is, because the button only needs one pin from the microcontroller.
Right, right.
So you can move this closer to where to the pin you are using in the microcontroller. So you could move this button here,
Yeah.
this thing here,
Yeah.
put these two things closer, and this is coming from VCC and ground, and then from these two pins here.
Yes.
So maybe you should put this in the other side,
Yeah.
and this is, let me check. Yeah, this is ground. This is ground. And the other two pins are coming from where? From the other side. You see that they are coming from the other side?
Yes, exactly.
This is, you are going around all of these things because you have to go from the other side. So this, you have to put it in the other side.
Yeah.
And this is what the auto root tells you with this. When it's doing all of this, you have to place the components closer to where they are going because otherwise you might find solutions like this that are very difficult.
Yeah.
Also, these traces are very thin,
Mm.
so I recommend you to to change the width of the traces to 16 mil at least.
Okay.
But yeah, when you do this, you look at you should move this to the other side, because these are the microcontroller pins are coming from here, and the other is coming from this one, so it will be easier to route from here. Then this will be free. You will be better if you put this here and the button at this side. So you just play moving things around and then running again the auto root.
Yes.
And when the auto root is more or less doing a good job, then you can manually fix it.
Okay.
Because with this position here that you have the components, the auto root is not being able to find a way to reach these two.
Right,
But this
exactly.
is because everything is in the opposite way.
Yeah. Okay.
Except for these two that we are correctly placed.
Okay.
Okay, and this is the LED.
Mm-hmm.
This LED is coming from the other side as well. You see?
Yeah. So basically, I'm going to follow the original, the FTDI chip, the Hello World chip, and I will put everything in the same place, except I will the two resistors, the LED and the button. I have to squeeze somewhere.
Yes, you should. You can start from this one or redrawing it yourself,
Yeah.
but placing it near, because
Yes.
this is going to be the same position all the time.
Yeah.
This has been found to be the best position for these components.
Yes.
So you have free space later.
Okay.
Yes, try to do it.
No, I'm trying to do it as fast as possible, but I didn't want to be very behind for the machine design because my responsibilities mean I have to document and I have to do the poster. So this past week when I returned, I was talking to the team, catching up because the first week I was not there. So just finding out everything about machine design.
Okay. Because from these weeks we have been doing 1 week for designing the circuit, milling it, 1 week for programming. This week that is coming is going to be all in the same week.
Yes.
And you not only have to make one, but you can have to make as much as you can.
Yes.
Mill, and I'm not meaning using the NILS design. The NILS design is not valid anymore. You have to design your own board.
Yeah.
So that's why you need to catch up in this as fast as possible. Otherwise, you will find inputs, outputs, and networking very, very, very complicated if you don't get used to the Eagle workflow.
Yeah, no, I'm trying to figure out the Eagle workflow. Although I feel maybe if I had started with another package like KiCad, I think it would have been easier. But now because I've started with Eagle, I have to finish everything with Eagle.
No, it's not going to be easier like with another package. I mean, you can ask Yogi, he tried almost all the packages.
Yeah.
But Eagle at least is necessary because everything you are going to find it. If you want to start from the work done from another student, you need Eagle.
Right,
Very,
right.
very few you are going to find with KiCad. So
Yes.
it is good that you learn this because you don't need to start from zero. You
Yeah,
can
no,
start
definitely.
from other people's design, modify it, because maybe you don't have one of the components, remove one component. You can work from other people's designs.
Yeah, all the tutorials and instructions are in Eagle, so at least that is helping.
Yeah, except for Neil's boards,
Yeah.
which are in CAD format. The rest you are going to find everything.
What does that open? What software does that use? The CAD format,
The Cocopelli.
the Cocopelli, right?
It's a little bit. It's not complicated, but it's more suited for coders.
Yes, yes. I think you need to
I
know
mean,
Python.
yes, you need to know a little bit of Python. No need to master Python, but a little bit. Like
Yeah,
with
yeah.
15 minutes of course of Python, you can work on it.
Right, yeah.
There are two kind of people, like more people who are more analytic, who can do abstraction, like they don't need to see what they are doing.
Yep.
For this kind of people, Cocopelli is right. It's the right tool. There are other kind of people who are more visual, like architects, designers. These
Right.
kind of people, they need to see what they are doing. They cannot just imagine. So for them is Eagle or like these tools, what you see is what creatives are more suitable.
Yeah. Eagle is not very user friendly. I mean, it's definitely more visual. I agree, but it's not. I mean, at least the free version is not very easy to use. I mean, you still have to dig into the tutorials.
Yeah, it's not supposed to be uh, self-explanatory, Eagle. You have to follow the tutorial for sure. This step you cannot miss. These two half-an-hour tutorials, one for the schematic and one for the board design.
Yeah, yeah.
If you need this, just revisit them
Mm-hmm.
and try to, while you are watching, you pause the video and you work on your board step
Yeah.
by step. Okay. So regarding the machine Cebu, now we are get to this. The mechanical parts, did you print all the required components so that
Print
you can make the machine moving manually?
this for the stages.
Yeah, I mean the machine. There was
Ah,
two steps. One is to making the machine, so
yeah.
you can do all the mechanical parts, print, 3D printed, laser cut, whatever, and then you can move them manually. And then the second part is about the stages that are coming,
Yeah.
that you can automate this machine.
Okay. So about the mechanical parts, so this is something yeah, other team, Edu and Puni, their team made. I will just show you. This is a stage, and the one I am designing, we will be printing just now. I mean, immediately after the session. So, like yesterday, we were kind of late for laser cutting. So we'll do it today. I will just show you this.
This is a guide.
Yadu, what is this?
Extruder.
This is, the mechanism which pushes the syringe
Excuse
for
me.
our chocolate 3D printer. So this is the end effector.
Oh, I see.
Yeah, the syringe
Oh,
has
I
to,
see.
we have to fit the syringe. Okay, not done yet. And this is our linear stage. What I'm holding is.
But wait, can you come back with this, Sibu? How can you push the shrinks with that?
So there is a motor over here, and there is a threaded rod here, right?
Okay, I
And
see it now.
platform over here. So when we
Okay,
press
the
it,
platform. Yeah, it's because of the platform.
yeah. So this is our linear stage. It's fully made of acrylic. We haven't used even one nut or bolt. Everything from uh, you know FabLab, except for the
Oh,
space.
this is very nice design, actually. Can you try to bend it in the Sibu, in the lower inertia?
Bend. It won't bend. It can bend slightly. It will bend.
No, I mean not break it into two. Just I want to see the bending resistance. Is it stiff? It feels stiff? Does it feel stiff, Sibu? I don't hear you.
Okay, but
Francis, actually, this is 3 pieces.
not very
It's
stiff.
3 pieces.
Ended.
It's a 3 pieces.
It's 2 pieces, no?
Yeah, it's 3 pieces of acrylic put together. They're all. I'm using some snap fit clips. It's like very, not even. They're not very fastened together very much. Like like not with great force and all. It's all just snap fit. Like you can just fit it and then start running it. Like it can't take much load, and it's not very stiff in the this direction. Not that stiff. You can actually bend it. Um, Not very much though. That's fine. Did you get it,
Kevin,
Frank?
what about when the load goes?
Yeah. So we can one way is like we are planning to put the load over here. So the load will appear in this direction, down. So not like
Mhm.
this. And even if we put a load over in this direction, uh, it won't be. I'm like this particular end effector. It won't have that much weight. But yeah, so this is only suitable for this particular end effector, not like for heavy load and all.
Actually.
But this
So
way, what we are planning to do.
how do you hold these states? Where do you
Um,
hold these states?
where do we that platform is not designed, like it's in the design. We have not made it yet. I think Yadu has posted a Sketchfab uh, page on that, like how our final thing is going to look like.
Who? Shibu?
Yadu, Yadu has
Ah,
posted
yeah.
in general, I believe. Yeah, he posted it again.
In general. Oh,
Yeah, it ended up being longer than we wanted it to be. This was meant to be for a different thing, so we are using very less of it. Less.
but this can only move till here until here. Very little movement, isn't it?
Yeah, yeah. We need only such little movement only. So this linear stage, I did it keeping in mind a different project, which required much longer than what we are doing over here. But then we changed our project, and we needed very little length.
Use the hole if you have a good long belt.
Yeah,
Cake is always
yeah. Cake can be big.
And the way you move this forth and backwards is what?
using belt, but I didn't add the belt in design. Modern belts. Using belts.
Okay. Using belts. Okay. Okay. Nice. But this is a three-axis machine.
Yeah. Actually, two axis and one end effector only.
Oh yeah. Yeah. One
Requires,
end
but
effect.
it requires three-axis motion, definitely.
It requires three axes, yes.
Yeah, it's like one is extruder, so
Okay, so this is your machine for team 2, Yadu.
yes, yes. This is our machine.
And Shibu, your machine is the last.
Our machine, we don't have like a single final design like that. Uh, so like bits and parts are designed in various softwares. Like some of the things are designed in Blender by Rashid. Some stuff I designed in OpenSCAD. So yeah, we will put everything together.
Okay. But you haven't reached the milestone of having a machine manually moving yet.
No, not yet.
Okay. Do you have any expected time for that, or?
The manual stage, I think it should be done like tomorrow by at least today evening, or I mean at the latest by tomorrow evening, because we just have to print 2 stages and it's ready. We just have to laser cut it 1 stage, see if everything is working, make the final tweaks and print. I mean cut the second stage.
Okay. The theory about the stages against the like 3D printing a lathe is that with the stages you don't need to think of what is the machine you want to do.
Yeah.
You just have the stages and you place them in any order you want. They will become a lathe or a CNC machine or whatever, a pizza cutter, a drawing machine, anything with not even knowing what is the machine you want to do. And this is a very important property of modularity, that you don't have to think of what machine. Like for this lab that you showed me at the very beginning, like for this team 1, this thing,
Yeah.
this is the lab. This, even if you print this will only become a lab.
Yeah.
Yeah, this. But it's okay. I mean, if you need a lab, and there is no need to make a modular machine for becoming a lathe. I mean, these modular machines can become a lathe, but that doesn't mean that they are better lathe than an actual lathe machine.
So
So
that's one thing. Like about the stages. What I'm making will be kind of modular only. So it will be like similar structures twice, and it will be like one top on top of the other. It will be like the stages, but it won't be as modular as the Nadia's stages. So I'm also trying to make something like that. So which is this page? This is 22, right? Okay, so what I'm trying to
this
make is
is
a
simple.
linear stage with a box kind of thing, which will be sliding on one axis, and then next stage will be like mounted on top of that box. So that's what I'm trying to make. It's also bit modular, not much modular. But my question is regarding the electronics. So we are planning to use the RAM's controller for the 3D printer.
Yes.
So what do you think about it?
For your, you mean your board with the RAMs,
Yeah.
or a normal RAMs with a controller?
Yeah, just the normal RAM's controller for RepRap kind of printers.
Yeah, I mean you can make this. The rest, I mean, this is gonna start here. Machine presentation starts in April 18,
Okay.
which is next Wednesday.
Okay.
Mm. I would wait for the stages to arrive, but
So, Francisco, I think
otherwise,
Neil said that this week will be the machine presentations, and if it spills over, it'll go on to next week. But yeah, so
yeah, we have many
the,
machines.
yeah. So
It's
I kind
gonna
of
be.
looked at, yeah. So I looked
Sorry?
at the FabNet and Gestalt. I looked at some of the code there, and I think the level of indirection is a lot. So there's like a Python interpreter, and there's a bunch of abstractions there, and then there's you kind of so you feel quite distant from the end machine. So I think the first step, what we'll do is we'll use a more direct approach, which is using the ramps and Pololu controller, and get that working. And then if the stages arrive in time, we can do a second iteration, which incorporates the the FabNet. But for now, I think a simple approach, which will make a two-axis machine, and in which we can put an end effector, which could be either the tool for the lathe or a pen or whatever it is, right? That's the goal right now for us. The first iteration, the fastest way we can get to that. So that's what we're going to be focusing on today and tomorrow.
Yes, this is a good approach. At the FabNet, only you need to get used to this. You don't need to understand everything behind the FabNet. I mean the Gestalt or whatever they call. But now, Neil has replaced the interface of this, because if you see at these examples, you need to hard code the coordinates. You have to find a tool that creates coordinates for feeding the machine in real time.
Right.
It's not like you don't have an interface to draw.
Correct.
And now with this thing they have done, you can draw or scan, like if it was the Fab models, an image, and it will convert this to the coordinates to feed the machine, to feed the FabNet.
Right. You're talking to about the mods JavaScript interface, right? Which gives you those components you can connect together and then do transformations and then get generated toolpath and then drive the controller directly from there or over Node.js or Python. That's what you're talking about, right?
Yes.
Yeah. So we'll do
still,
that. We'll probably do that as a second or third iteration. I think first one we'll do a more direct one and hard code the coordinates and the instructions as you said, and then we'll do the next one. We'll refine that.
Okay. Yeah, sure. When these things arrive to you, I mean, if you have this already automated in the sense of you have already placed the motors and all of this, it's going to be much easier.
Right. 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 Also, from a learning perspective, I think working directly at the lower level is much better to kind of understand what's really happening, and then go to the abstractions. So, yeah.
Yeah, sure. And even that Nadia is doing this FabNet, and she is very good at doing these things, but she is very bad at documenting.
Yeah. I looked a lot for the documentation for FabNet. I found one page. It's terrible, actually. Really bad.
Yeah. So here you are like 300 people wondering how this thing works.
Yeah.
Because she didn't do a
That's true. It's
documentation page.
not convenient, actually. But yeah, whatever. We'll figure it out.
Okay, so this is for now, Cebu. Sorry, we need to check locally and Vinod. The next weeks they are coming. There is only electronic weeks like outputs, networking, inputs, and interface. They are only programming. You don't need any material. Just you can work in the computer. You don't need even to be in the lab. Just for milling the boards you are going to make. But there are two fabrication weeks left, which are composites and composites and molding and casting. So molding and casting, it will need the wax that you already have. Have you tried to melt wax already?
No, we haven't.
You should try to melt wax.
Yeah, the rest of the
remains
wax.
of
Okay.
the chips and all of this.
How do we do that?
I have done it.
No.
You just have to have it's a slow process. You have to do it in a pot, but you have to be careful because this paraffin that is inside the wax,
Yeah, it is
I mean, this
inflammable.
wax is, yeah, it's flammable at maybe 300, if I recall correctly. So you have to warm it below this temperature.
Right.
You have to put a thermometer inside.
So Sibu has some experience with it. He has done it seems.
Sibu, you have some experience?
Yes. So
I mean,
during the pre-academy, these people at Kochi, they didn't knew that this wax has to be recycled and stuff. So they use a vacuum cleaner for everything. They used to take the chips from the modella. They use it to clean the dust on the floor. Everything they use. So they had one bag full of this wax chips with a lot of bits and pieces of copper. Everything was there. So they were going to throw it. So then I took it home and I kind of melted it and kept it melted for a full night, overnight. And then I got it separated. So all the heavy parts went down, settled down, and all the lighter parts came up. Then I just had to chop the both end. So
How did he melt it?
yeah, melting, I kind of did use the charcoal. Just make sure I didn't have any temperature control or anything.
Hot charcoal.
Yeah.
you mean for the bubbles?
Oh, no, not the bubbles.
No, for heating,
For heating, I use charcoal and a small kind of makeshift blower.
Hmm.
And then once I had this separated for the final cleaning, I use just the stove, kitchen stove, and a metallic tube.
Okay.
That was kind of more controlled environment, but the first one was just crude. I took a steel glass and put everything in there and heated it.
Okay. Yes, for melting these components, you need three things. You need an enclosure, but after you melt, you put the wax in this enclosure that you can make with a laser cut box that you fabricate. That is the exact shape of the of the of the block wax blocks as you have. The second thing you have is a temperature control cook or heat source. You can do this in any convenience store. In here they sell these personal electric cookers that you can set the temperature, like induction.
Yeah, here we have two options. We can either use the furnace or we can use the oven.
Yeah, you can also use that. And finally, you need like a vacuum for removing the bubbles.
Bubbles, yeah.
You need this vacuum.
Francis, I have a doubt. It's more
Yes.
heated the wax. There is no possible to.
Keep the mic away from your mouth, like
Okay.
just.
You know it.
Yeah, fine. Sorry.
Yeah, it's much better now.
Okay. Francis, I said more heated the wax. There is no chance to occur the bubbles.
Yeah, for removing bubbles, he's suggesting we use vacuum.
Okay.
Yeah, vacuum. Yeah, when you pour this into the enclosure, into the final enclosure, you have to put this like for a few minutes in a vacuum environment, because when it's liquid, it's very easy to remove the bubbles.
Okay.
When it's still liquid, you put this in vacuum, the bubbles will go up very fast.
Yeah.
Doesn't have to
Frank,
be
yeah, there are two
slide
things,
vacuum.
Frank.
Yes?
Okay, so when you heat this wax, it actually expands, and when you like when it cools down, it shrinks. So not by much, but it does happen. And now there is one more thing. Like if we make a box to contain this, I mean, once we melt it and we need some kind of box, right? So if we use acrylic, it's not going to withstand. First of all, the temperature is too high. Acrylic will become soft, and this paraffin is very sticky. It will stick to the acrylic box. So we need to use something else, like a metallic thing.
We use, I mean, everyone uses the MDF,
Yeah,
MDF,
okay, that will stay. Yeah, but again, MDF
laser cut.
it will stick
It
to
doesn't
MDF.
stick at all.
If it doesn't stick,
No,
The
it
laminated.
doesn't stick at all to this, because when it's going to dry, it's going even to shrink
yeah,
slightly,
yeah.
so it will be completely separated.
Oh,
Actually,
okay.
So you're talking about laminated MDF.
it's just normal MDF.
Okay.
You're not going to stick it to it. Don't worry about that. And the only thing you have to make slightly taller than you need, because when you are moving these things around, I mean, the wax is going to be moving as well, so make the container taller than needed, and leave always like 1 centimeter from the top border. Don't try to put the wax until the top of the container. So I recommend you that in each of the labs, at least one of the works you do this process, so you can see how you need to do this in case of needed, and then the rest students use the normal blocks. Okay, and after that you can recycle them. But wax is one thing. Okay, this lasts forever, no problem. The problem is with silicone. Silicone, you only need to buy the quantity you need, and you only need to
We have some 2 kg of silicon. Depends on what.
only the quantity you need, and only when you need it, because it doesn't even last for 6 months, even in the shelf. So, Puneet, have you found a source for silicon?
There are some fab, Amazon sellers
This one is very costly, right?
like that. Like a bucket cost 5,000 or something. Definitely the smooth on and all cost like even a jar, a small jar, 1 kg jar, that is costing 5,000. And I've seen some other vendors in Amazon, like a whole bucket, maybe 5 kg, that costs 5,000. But we don't know like
Yeah.
what quality it is, and then how they measure, like what kind of silicone it is. I don't know about that.
Yeah, but
Is there anything specific I have to look at? Some how they grade this silicone.
yeah, here you will need to use the silicone you have, because I think it's already. Do you still have homo silicone?
Yeah, the clear silicon is still working. It is still potent.
Clear one.
Yeah, clear one. Clear one is potent, and then the the tin curable silicon mold max 60, that is also good.
The thin curable.
Yeah, the tin cure silicon.
Uh-huh.
Yeah, that is also good.
Because you will need to use the silicon that you have in the shelf before buying any other.
Okay.
Because even if you don't use the silicon on the shelf, it will go. If you don't have any project for that, it will go very bad. Like it will go unusable. So be not, if you have a project where silicon is needed, it is the time for executing this, because you will have a lot of people using silicon.
Yeah, I think we don't have enough quantity for all the 14 of us. We have some 2 kg or 3 kg right now. I'm just estimating. Sorry, Vinod, hang on, I muted you. Yeah.
Yeah, we have I think we have a 10 actually 10 in the first show. Nearby two or three pieces we used. It's 7 is remaining.
Okay. Then liquid plastic. You have some as well, isn't it?
Some of what? Plastic. Yeah, yeah. We have plastic.
Liquid plastic.
Liquid plastic, yes.
Okay. And you have gesso. You have the hydrostone thing.
Yeah.
We have.
No.
Okay. But this is okay, and you have the metal thing.
Yeah, yeah. Metal we have.
Perfect. So we have enough of this. The only thing is the vacuum bags and the household vacuum cleaner. Have you
Yeah, the
find a
vacuum,
source?
the vacuum bag, I bought it. 3 of them currently for testing. It's yet to come. It is shipping.
Okay. How big are them?
60 by 80.
60 by 80 is okay. 60 by 80. Do you have any kind of shading or something like this for doing double side molding? A big shading?
A big, you mean a container?
No, shading.
String.
No, shading.
Sharing.
Shading.
Sink. Like, is that
Oh,
a
let
big
me.
container? Like a sandbox?
No, I mean this, like.
Oh, syringe.
Oh, syringe.
Syringe, yeah.
We don't
A
have
big
big
syringe
ones. We
For what?
with a big diameter here for doing the injection
For
in a double
injecting
side
what?
mold.
Injection molding.
Oh,
Yeah.
double-sided.
Okay, we have to get it.
No, we don't have it.
We don't have it in the lab.
I mean a big, like for cooking. They sell it for cooking. It's a syringe like very big. And with this diameter is also very big.
Okay.
And it has like a metallic, a very big metallic tip. I think in every convenience store you are going to find this.
Okay.
It is very big.
Nobody uses this for cooking. Yeah, we need to.
I think I know. Here, look.
Don't edit that. Oh no, no, no. Frank, if we edit that, you lose visual and gone.
No, no.
How? Because he.
Okay, wrong button again. Here, look.
We are seeing you.
Yeah.
So what did you do?
Here,
Just edit your Hangout window and went somewhere.
okay. This is actually this is Barcelona. No. This one. This sharing, like this big.
This is medical one. Yeah, we can get it.
No, this is not medical. It's for cooking.
Wow, is it?
It's very big.
Okay.
I mean, if
This
you
big.
have something medical that needs this sharing, you are really bad.
They use it on animals mainly. In a big syringe.
Yeah, we get this same thing in animal hospital, veterinary hospital.
Well, whatever. It's either this one or I mean, I bought this in a convenience store for cooking. It was used for cooking, like for doing like this kind of sharings that you need for writing with chocolate and all of this. This is the perfect thing you have. Or anything like this. And then for composites, it's about the only thing is the resin. Neil is very insistent in the resin, in the resin, in the resin. I mean, for me, I mean, it's many people using natural things like natural resins or doing any kind of composites, but Neil he wants you to have the resin. So do you have the resin?
What are the natural resins?
Yeah, I mean, these people doing paper with sugar or with honey,
What are those?
like natural things.
So
Doing
we use
composites with natural materials.
cellulose as a fiber.
Many
And
people doing this.
many.
Not using the resins,
We can use
but using composites. Composite is a layer of material, layer of
they settle in the hard core.
the resin, but you can use any natural thing that acts as resin and any material that acts as the substrate.
Okay.
But about the resin,
Frank,
any for the matrix. Yeah,
Frank,
there's many people using this natural
for sugars.
resins.
Plant resin, yeah. Sugar?
Yeah, sugar becomes like resin when it dries.
An entire dam made out of sugar. I mean,
He wants you to have this. We are going to use this cotton, I mean, natural material, burlap, with this epoxy. This is what everyone is going to use. You can use whatever you want.
Yeah, other issue, the controversial one between Tamil
I mean, since you are both near the coast, you shouldn't have any problem to find resin, because this is the resin they use for repairing boats, fiberglass boats.
They use polyester over here. We've gone there. They only had polyester. They didn't have epoxy.
polyurethane also.
Did you have
Yeah, polyester, right? They had polyester.
I think this is better, apart from the mechanical properties, for the security shit.
Yeah. I know that's a much safer option.
But if you don't find the epoxy one, like in marine environments, they have epoxy for sure.
Yeah, we'll try to figure out a good tip making company over here and then check out how they get.
It comes in two components. This is the brand they recommend. But still, this is a few weeks from now, so you still have some time to find a way. In the very
Does Vigyan Ashram have epoxy? They have a source for epoxy. Maybe someone from Mumbai. And we can just source it
no,
from
they are using natural things. Because Vigyan Ashram is like a very natural place. Like they don't want to hear anything about this. Which is right. I mean, there are natural resources that you can use.
Puneet,
But if you want to make like something like really hard, you have to use epoxy, like, and water resistant, and like a shell, like a structure for a boat, or you have to use epoxy.
In small quantities you can get.
Okay.
yeah, Puneet.
Yes.
Puneet.
Puneet?
Sorry. Puneet. We have some polyester cloth in our store.
polyester. What we have? I mean, I
Cloth,
have
cloth.
cloth, polyester cloth.
Yeah.
For what?
What's the purpose for that? The cloth.
What are you talking about? I don't get you first.
Yeah. Okay. Fine. Just come with a lab and just talk with it.
Okay.
Yeah.
Fine.
Okay. So in short, for now, put the machine assignment in a second. Sorry.
Yeah, so I was saying we can get the epoxy resin in small quantities. Like they are used for glue, right? To like you mix to like araldite kind of thing.
Oh, those are not very strong.
Yeah, that's strong.
No.
Yeah, I know, but no, this is not valid. You need more quantity than that.
Yeah,
You need liquid resin.
No, I'm not talking about
And this also has a different consistency. Like it is.
it's very hard. It's very hard.
It smells the same actually, but it has different consistency. The one we are using is more liquid. Like you can dip the cloth inside of it.
You compare
So
yeah. This is not that way.
let's do that thing. If you find something in the internet locally for epoxy resin, it is okay. Otherwise, we find a different. We try to do another thing.
Okay.
What do you recommend for some kind of biocompatible? Like if we are going to make something that can be worn, or maybe like like how about biocompatible? Which one is safe? The silicone here we have, is it biocompatible? I mean, is it
You mean
safe?
for molding and casting?
Yeah. I mean, no, I'm not talking about handling. Suppose I make a strap for a watch, for example, or
Yeah.
I make my own customized in-ear, earphones. So can I do that with any of the component here? Like we have silicone, we have some polyester, polyurethane based.
No, definitely nothing like this. Not polyurethane or all
It's
of
not
this. You
good.
can do that. Use the food safe silicone or the normal silicone. Like silicone is neutral. Like you can use anything. If you are very worried about allergies and so, use food safe silicone. The only thing food safe silicone is pink. I don't know if your design or the earphones are going to withstand the pink
The
silicone.
clear silicone is not food safe?
The what?
The,
Food safe is
clear.
pink.
Oh, okay. I thought
I'm not.
Luciano said the clear silicone was also safe.
You have a clear silicone food safe as well. It can be, but the smooth on we have in here is pink only.
Oh, pink.
Okay.
Right.
But if you have
Maybe,
a pink, clear one, which is silicone safe, this is the better.
but maybe it is skin safe, like for wearables.
Yeah, I mean,
Safe for the
the
skin.
silicone is neutral.
Okay.
It's skin safe. But not the polyurethane and all the urethane rubber, all of this, never even think of put this in your skin or whatever. It's super toxic.
Polyethylene must be good, right?
We have urethane rubber, we have silicone. I don't think we have any other thing in the inventory. You have the urethane rubber, isn't it?
No, we don't have.
Do you have any?
We have urethane plastic only, not rubber.
Yeah, also a rubber.
Yeah, the rubber also, but we don't have.
Oh, it's better. It's very toxic, very, very toxic. So what I was saying is just no, stop sharing. Just leave the machine assignment. Put this aside, like in a second plane of priority now, and now start taking all the things in place for working with input devices. I mean, have your toolchain ready, like check that your toolchain is ready, like your programmers, your softwares are working, test them, and test your workflows, have them ready, because this week we are going to do a lot of things with electronics, and we have to be very fast on doing that. Very fast on fabricating, very fast debugging. So this is one of the most complicated weeks to electronics.
Frank?
Yes.
Okay, so for this this week I am planning to make one single board with a rotary switch. The rotary switch like in the Ultimaker. We have that selection now, right?
For the Ultimaker, sorry, for what?
Okay, so what I'm planning to make is a single board which can be used to test either a servo motor or a stepper motor. Okay, so it will have a 80 tiny. It will have connectors for servos and stepper, and now there will be a rotary switch as input. Okay,
Okay.
and so can it be considered an assignment for this week? Like
For
you
input
can
devices.
input and output. This has input and as output, right?
Yeah. What is the input again?
Input is a rotary switch, rotary encoder. You remember the Altimakers, the menu selection? We have a like rotating wheel and push button embedded.
Yes.
So that's what that will be my input.
Yeah, a rotary encoder,
Yeah.
not a potentiometer.
Hmm?
Not a potentiometer.
No, not a potentiometer.
A rotary encoder. Okay, yes. It can be considered like an input device. Very simple, but yes. Yes, it can
So
be considered.
yeah, so I'll be
Things that
using.
cannot be considered should be like something like a button, like super simple.
Oh,
I mean, a button is an input device, but it's not for this level. It's like for really newbies, and you already have done that. Like a
yeah.
button, something that doesn't even have a data sheet, like for data.
Yeah, rotor
Like
switch is not that simple, like a button. It produces pulses, and you need to interpret that pulses.
yeah, this is okay. A potentiometer, it's an analog device for input, like at the very low level can be considered, but because you still have to do some operations to read the voltage.
Hmm.
So yeah, but I want you to make something like to read data, like this you said, like reading pulses, digital pulses and or analog signals. You can make both for this week, one digital reading and one analog reading.
Yeah,
It will be fine.
yeah.
What is not going to be considered is like something like a GPS. GPS is sending data. Well, yes, it can be considered like sending data through serial connection. It's more like a networking and communication week.
Not actually. If you say like that, then if GPS module cannot be considered, then GPS, accelerometer, gyro, all these modules will just disappear because they all give similar kind of data to the you know. If you take the bare
Yeah,
GPS chip, that's a different thing. But if you take the modules, then they all communicate through serial bus.
yeah. It's taking the component, just the component, like the accelerometer. But still, I think it's doing I2C.
Yeah.
I think it's still doing I2C, like the input devices, temperature, output consistor. Yeah, it's I2C.
Yeah.
It should be networking week actually, but he's putting them in input devices. So if he's doing that, this is a networking thing more than an input device.
But you're getting a data, so that's input. Whether it's networked or not, you're getting a data in, so that's input. Technically qualified to be in input week.
Yeah. Okay, then a GPS is also valid according to this criteria.
UPS?
Yeah, GPS is just sending
Oh,
serial
GPS.
data.
Yeah, it's valid.
You
Should be.
have to parse. You have to parse the data, and that's it. You have the difference. Okay, so please put this in the machine in a second plane of priority. and get ready for these input devices, which is actually more important than the machine assignment now.
Okay. Okay.
Okay.
Okay.
So maybe for this week, it's better you only work in the machine assignment, in the input devices, and then the week after that we have molding and casting, we finish the machine assignment. Put this aside unless you have to fabricate things that you don't have to worry about, like you put this in the 3D printer and that's it. This is okay. But put all your efforts in these input devices, okay? We will try to do some input step response sensors, which are very useful because it's the only ones that you can fabricate. The rest you have to buy. But input devices, step response input devices, this you can fabricate in the Fab Lab. It can be anything: force, tilt, acceleration, and it's just pieces of copper. It's very important. So and very difficult. You need to master a little bit the oscilloscope. We will do a little bit of all of this. So get ready for tomorrow. Go to the recitation this afternoon, please. Looks like interesting. Okay? See you tomorrow then. Bye-bye.
எல்லாரும் கரெக்டாக வயர்